right, the third sheet. The third sheet's going to go into 4 groups. The last 4 groups. Notice in here we're going to have not just one oxygen here, but 2 oxygens on the same atom, same carbon atom. That chain that has the 2 oxygens on is called the parent chain. That's the carbon you're going to start counting back from to see what's the name of that compound. If it's only 1 carbon, what do you call 1 carbon chain? Methane. And then you're going to put the word oic acid. So methanoic acid is what ants actually, when they bite you, that's what they're injecting into us. And that's where we used to get formic acid all the time. Ethanoic acid or acetic acid, ethanoic meaning 2 carbons, ethane, and then oic acid is what we put in vinegar. So that's just 2 carbons. Ethanoic acid is a dye that helps to fix dyes into clothing. But notice that's still 1, 2 carbons. The bens are the carbons, and then at the end of every stick there's a different atom. Then you don't count those as the carbons. So here you've got an acid group there and an acid group there. So 2 carbons. Oops, and this should have actually. Just notice this doesn't have those in. So let's put those in. Oxygen, oxygen. So that's different than I mean, this is wrong in the notes, but this form is right, but that isn't written correctly in the long form. Esters are going to be our next group, and now how do esters differ from acids? You're going to notice instead of having an OH group here, it's going to have another carbon chain. So it's still got 2 oxygens. These are great paint thinners or paint strippers. A lot of these are going to end up being really good solvents. So what you're going to notice, though, is that there's the 1 carbon that has the 2 oxygens. That's the side that's going to be named the parent. So instead of oic acid, like we had for there, and you could tell because the H was on the oxygen, here you're going to notice here's a 1 carbon chain that's got the 2 oxygens. This is a 2 carbon chain. So this, because it's got both oxygens, is the parent. Methanoate. 1 carbon, methane, and then O8 is the name of the parent. What's left are these 2 carbons on the oxygen, just as a single side chain is ethyl methanoate. Now, some of these have fantastic smells, like the smell of an orange, for instance, is ethanoate. So here's the carbon that has the 2 oxygens, ethane, noate. And then here's the carbon side chain that's got 8 through there. Almost all the fruits have grapes, bananas, pineapples, that kind of stuff are esters. Okay, let's finish with the last 2 compounds. Those were compounds that had 2 oxygens on it, 1 double bonded, 1 single bonded, and these last 2 are ones that have a double bond somewhere in the chain, just a double bonded oxygen. If it's at the end of the chain, the last carbon in the chain is called an aldehyde, and you just replace the E with an Al. So 3 carbons long, propane, and drop the E off, it's propanal. Okay, methanal is just 1 carbon with a double bond on it. Some of them are spice smells, like cinnamon. Cinnamaldehyde is the molecule for cinnamon, or vanilla, and bitter almonds. So all of those are actually, they're different natural extracts, but they give some characteristic smells. But the methanal or the propanal are the 2 examples that should help you to solve the problems that are on the worksheet. 1 carbon chain with a double bond, or 2 carbon chain, or 3 carbon chain. Now, on these cases, ketones, the last one, and they're very similar. It's just that the double bonded oxygen is somewhere in the middle of the chain. So in this case, then I'll have to back up. This should be an oxygen right here. If you look, 1, 2, 3 carbons. And this actually has to be. Let me see if I won't be able to move that. That's actually got to be in this middle carbon here. So let's do this, and it should be right there in the middle. Propanone, and that's what you use fingernail polish remover or other kinds of like super glue remover. This double bond is in the middle of the chain again. That's cyclohexanone. You don't have to do the cyclose. But that's just the double bonded oxygen is in the middle. It's got an ONE, own, ketone, and if it's the end, it's an al. So those are your last ones. Here's a quick summary of all the kinds of things that you're going to be naming. Don't forget, find the longest chain first. That includes the functional group or double bond or triple bond. Then you name that longest chain and put an appropriate ending if it's got oxygen groups. Aldehyde, all for alcohols. Oic acid for acids. Name any side chains, but name them alphabetically. And then you want to number the carbon chain first so that the functional group, the oxygen and nitrogen, get the lowest number. The triple bonds or double bonds get the, if there's no functional groups, then the triple or double bonds should take priority in numbering the carbon chain. The carbon side chains next, and then the CLs, BRs, if you can get them with lowest numbers. Finally, side chains are numbered from, side chains that have side chains are numbered from branching points, but I didn't give you any of these examples. So just these first 4 are going to be great review, and they're right there on your notes for you. Good luck in finishing those. I will send you I'll put the answers on as well for you on the online site. Thanks.